I prefer sunsets over sunrises because I'm never up early enough.
I'm with you.
Yeah, I think
Same
Jake
here.
will tell us more about
Night
both.
owls.
Yeah.
Yeah.
So it's a consensus then, right?
But it's interesting how we define sunrises and sunsets, and you might have noticed this, it's only by a couple minutes here, but there's an interesting quirk with our sunrises and sunsets around the winter solstice, where our earliest sunset actually occurred about a week and a half ago on December 10th and 11th. Tomorrow is the first day of winter. That has the least daylight, with about an 8.5 hour amount of daylight during the day, but it's kind of counterintuitive here how the latest sunrise is also past that. So you're kind of squishing the day. You know, you would think that the latest sunrise and the earliest sunset would be on the day with least daylight, but in fact, they're offset, with the earliest sunset occurring a couple weeks ago and our latest sunrise still yet to come. So the earliest sunset of the year, again, happened December 10th and 11th when we had sunset around 4:55, a few seconds later each day after that until this point, first day of winter tomorrow, when our sunset will be around 4:57 in the Bismarck area, but this applies elsewhere. Again, tomorrow having the least daylight of the year, and that's just because our sunrises have continued to get later, again, squishing the amount of daylight that we have. For other areas across our region, December 10th and 11th, our sunset was a couple minutes earlier than our sunset is for tomorrow. So again, our sunsets have been getting later. We're adding some daylight in the evenings, even though we haven't arrived at the shortest amount of daylight of the year yet. And again, that's for tomorrow. One factor in the reasoning behind this is our latitude, or our distance from the equator. Right up here in North Dakota, again, our earliest sunset of the year is around the 10th or 11th of December. It would be earlier or even further ahead of that winter solstice if we were closer to the equator, farther south. So again, reminder, earliest sunset, we had that about a week and a half ago. Latest sunrise is still yet to come on January 1st and 2nd of next year. So our latest sunrises of the year, right now we're seeing sunrise around 8:25 a.m. with the least daylight of the year tomorrow. A few seconds later each day after that for our sunrises still until January 1st and 2nd. So we're adding a couple minutes here. Sunrise around 8:28 a.m. on January 1st and 2nd. And again, looking throughout the region, it's only a couple minute difference for tomorrow, first day of winter. Here's our sunrise times. Add about 3 minutes to that for getting our sunrises even a little bit later into the morning before we start gaining daylight in the mornings. That's going to come after January 1st and 2nd. So some interesting things here, a little bit counterintuitive. Again, based on our latitude or our distance from the equator dictating the latest sunrise date of the year. And again, our latest sunrise will be around January 1st or 2nd. Here, it would be even later in January if we were farther to the south. So one of the core concepts here is the solar day, and that dictates if you take the sun directly overhead at solar noon, you take that one day to the next day. That's defined as our solar day, from sun right overhead one day to sun right overhead the next day. And that is actually a little bit different than how we define a length of a day based on the clock. So the reason why the earliest sunset and the latest sunrise isn't on the day with the least daylight, tomorrow, the first day of winter, is because of that discrepancy between the clock and the sun. While the length of a day is defined as 24 hours long on our clocks, on our watches, in reality it varies slightly due to the spin and tilt of the Earth, that's one reason, and our elliptical orbit around the sun. So the actual length is defined as that solar day that we just talked about, and its length can vary from a few seconds to 30 seconds longer or shorter than actual 24 hours. So with the spin and tilt of the Earth has to make slightly more than one turn to line up with the sun, to get that sun directly overhead from one day to the next. Because we're revolving around the sun here, it has to make slightly more than one turn to line up with the sun. Now, the other reason with the elliptical orbit here, Earth's orbit is actually oval shaped, so we're closest to the sun in January and farthest from the sun in July, and this affects the speed of our orbit and the length of that solar day. So here's how the change in the length of the solar day occurs from January through December. Near the winter and summer solstices, our solar day is more than 24 hours long, and near the spring and fall equinoxes, it's less than 24 hours long. Therefore, near the solstices, like we are right now, first day of winter tomorrow, solar noon occurs at a slightly later clock time each day because the solar day is more than 24 hours, and the clock day is always exactly 24 hours, and that in turn impacts when our sunrises and sunsets occur. Some other interesting things with the sun in the sky: in winter it's a lot lower on the horizon than in the summer, of course, and with the tilt of the earth, when we're tilted away from the sun, we're in winter here in the northern hemisphere, and the sun actually makes this elliptical pattern in the sky. If you were to take a picture of the sun at solar noon each day, the sun's position kind of changes like this, because of the tilt and because of our elliptical orbit around the sun. So all of those factors come into play, dictating why we have our earliest sunrises, or the sunrises and sunsets, the earliest and latest ones, are offset from our shortest daylight of the year tomorrow. Now, there is one last little key bit here, is that the way we define sunrises and sunsets is a little bit unique because of the refraction of our atmosphere. So the way that we would see the sun is actually a little bit higher up on the horizon, because when the sunlight goes through our atmosphere, which is thick with a bunch of different molecules and particles, it can bend that light. So sunrise occurs the moment the disk of the sun peaks above the eastern horizon due to the Earth's rotation, whereas sunset is the opposite. It occurs the moment the disk of the sun completely disappears below that western horizon. So some interesting ways that we define sunrise and sunset, but take-home message: we're going to be gaining daylight day by day after we get past that winter solstice tomorrow, even though our latest sunrise occurs on January 1st. By the time we get into March, look at those sunrise and sunset times. We're going to be increasing the amount of daylight we have as we approach that spring season. So looking up from here, but interesting how the sunrise and sunset, the earliest and latest ones, are kind of offset from our winter solstice tomorrow.
So true. Have you ever seen a spoon in a glass of water bends? It's kind of like those atmospheric optics too. Same concept. Take a spoon, glass of water, you'll see it bend. Yeah.
Sure.
Atmospheric optics does the same
Refraction.
thing.
Yep.
Refraction.
You guys,
Yeah.
they really get into it.
We geek out. We love it. Yeah.